Some problems are a little less straightforward than just using PV equals nRT. So this next bullet is looking at determining density or molar mass of the gas. So what's the density of sulfur dioxide gas at 22 degrees Celsius and 734 milliliters of Hg? So you see we're getting a temperature and we're getting a pressure. So if you think about it, density is mass over volume. Now for gases, it's going to be grams per liter. So you're going to be solving for either volume or moles. So the easiest thing to do is look at that you know what this gas is. So you know that you have 1 mole of that, and you know that it is going to be 64.06 grams per mole. So I can just get that directly from the periodic tables. It's a 6. So I always solve for volume. Assume 1 mole, and then that will be your 64.06 will be your top number. So I'm going to do V equals nRT over P. Again, I'm going to cross multiply, get PV equals nRT. So I'm going to put in 1 mole. I have millimeters of mercury, which is the same as torr, so I'm going to use that 63.36 torr liter per mole Kelvin. I'm going to do 22 plus 273, and I can do that kind of separately, 295K, and I can write it in either way, it doesn't matter. And my 734 torr. So remember, torr is the same as millimeters of mercury. So again, all my units should cancel except for liters. So that's going to give me 25.1 liters. So I know my 64.06 grams, and I know my 25.1 liters. So I'm just going to divide those two out and get 2.55 grams per liter. For this problem, I have 741 torr, so we have a pressure, and I have 44 degrees Celsius with temperature. I have a mass of the gas and a volume of 5.4 liters. So the only thing I don't have is moles, and if you think about what molar mass is, it's the number of grams per mole. So I have this gram thing, but I don't really need that yet, so I'm going to be solving PV equals nRT for moles. Okay, and that gives me N equals PV over RT, and then I'm just going to substitute in my pressures and my temperatures and my volumes and my RBEP. So that gives me 741 torr times 5.40 liters divided by 62.36 torr liters per mole Kelvin times 317 Kelvin. Again, checking units to make sure I have everything in correctly, is going to give me a N value of 0.202 moles. So for molar mass, then, I just need to take that 7.10 grams and divide it by my 0.202 moles to get units of grams per mole. And it's going to give you 35.1 grams per mole. And if you don't think you're going to remember that, you can always solve for 1 mole and then how many grams, and you're going to do the same thing, so you'll see this exact same thing substitute in, but if that feels a little easier for you, that's certainly acceptable.